Hello everyone, so we have created a perfect diagram for our purpose. So with the resistor and all, we resistor LED. So this resistor has one resistance, let's say 330 ohm. Other resistors have different resistance, so maybe 1 kilo ohm or something. Okay, so we are good with the circuit. Okay, so this is the on switch, and this is the off switch. Forgive me for my writing. Nothing to do. So this is off switch. Okay, which one? This one. Okay, let's have a control set. Let's not have much pictures. Let's see. Okay, I'll have it a little bit close to the switch. That's what I'm trying to do. Off switch. Okay, nice. Now everything is clear. So now just to quickly go through. So line number 33 has connected this diagram. So initially the pin number 33 will be at plus 5 voltage, and this on button is connected to that. So if you press the on button, that is already connected to ground. Okay, so this pin number 33 will be immediately connected to ground. Okay, so that will become low or 0 or ground. So that means on button is pressed. So 33 will become ground or 0. Likewise, 35 is connected to resistor. Okay, pin number 35 is connected to a resistor, and the resistor is again going to the plus 5. So initially 35 is plus 5, and when you press the off button, so the connection is created to the ground. So 35 will become ground. Okay, so all we have done is we have studied about the single buttons. Now we have studied about two single buttons with two different pins. That's all. Okay, so when you press the off button, 35 will become ground. So that's all. And an LED is going from 31, and that is properly connected, and the other side is let's say with the 330 ohm resistor, other side is going to the ground. So we can switch on and switch off an LED. Are we good with this or not? We are really good with this. Okay, so first let's try to take the inputs and write the essential code, and let's think it further. Okay, so what I will do is I will remove all these unnecessary things except the index. Okay, and since I am taking two inputs, I am creating another variable as well. Let's name it as int y. Okay, so now we have completed the diagram creation. Okay, and now we are moving to the coding part. Okay, part 2. So I hope you have created the same diagram, maybe with different pins, and let's verify whether your code is also same as mine. Okay, so let's write, since we are going to take two inputs from pin number 32 and 33, 33 and 35, let's write two pin modes for them. So let's write pin mode 33 input. Okay, also let's try the same to pin mode. Let's write the same to pin pin number 35 as well, because that also having a switch button, input button. Okay, so I will make it as pin number 35. Why? We have two switches, one is connected to 33 and the other one is connected to 35. Okay, 33 and 35, two switches. On pin is 33, off pin is 35. Okay, nice. Now we have write another pin mode. Why? We have an LED connected to 31, so that should be an output pin mode. Okay, so I am writing pin mode. What is the pin? 31 LED, right? 31 output. Are we good or not? We are good up to now. Okay, so now what should we write inside the void loop? We have to take two inputs from the pin number 33 and 35. We have to keep reading the inputs of pin number 33 and 35. Why? Because we have to keep reading on switch and off switch, whether on switch is pressed or off switch pressed. We have to keep reading at every iteration. Okay, so how to read it? We will write digital read. So first we will read the first on button. So I know the number of this pin number for the on button is 33, so I will make it as 33, digital read 33, and I will assign it to X. Okay, so X is the on button. Okay, so you can add a comment if you want, on button. Okay, and Y we will use as an off button, so that you can always refer if you are missing or confused somewhere. Okay. Okay, so now we are good. We are ready to read, and we are reading the input for pin number 33. That means we are reading the on button's input. We are good. Okay. Now let's go to the other side. I mean, we are just going to do. I'm just going to duplicate it because I'm going to read the next pin now. Off button. So that is the only thing is pin change. Why? Off button is in the pin number 35. Okay. See, pin number 35. Okay. So now I am going to read pin number 35 where off button is connected. 35. Okay. So now what I am going to do is I have added digital read 35. So and I will assign it to y. Okay. Two different variables, two different inputs. Okay. Now we are reading both on button and off button. We are good. So what we are supposed to do now is writing the logic. What should happen when the on button is pressed and what should happen when the off button is pressed. That's all we are supposed to do. Okay. So let's look at the task again. We are reading that, but what we have to do is when on button is pressed, I have to switch on the LED. When off button is pressed, I have to switch off the LED. Okay. Nice. So I will write an if condition, and I am planning to write the on button part first. Okay. So I will write if. Okay. What is the on button value? X. X is equal to what value? Ground, right? Because when on button is pressed, 31 or 33 input value will be ground, right? 0. Okay. So I will write 0. That means on button is pressed. Yes or no? Because it is digital input pull up. So pressed means 0. So I will write an if condition. So what should happen on button is pressed? We have to switch on the LED. So what is the LED pin? 31. So how to switch on an LED? Digital right X, not X, 31 high. Okay. Now we are good because we have written the half, because when the on button is pressed, LED is on. Okay. Wait. Earlier what we did, we wrote an else part. That means if the empty else part. Okay. So that means the opposite scenario. What is if it becomes false? That means on button is not 0. Then obviously else mean what? It is 1. So at that time we switched on the LED. That means if you take your hand off, that means X become 1 and LED goes off. Now we cannot do it, because to switch off an LED we are going to have a separate pin. That is the Y thing. So this is the difference from what we have studied up to now. So now you have to use your brain how you can do it. Okay. So you cannot write an else and switch off an LED. If you do so, if you write an else part and if you switch off the LED, what will happen? When you even take your hand off from the on button, LED will go off. But to switch off an LED, we want to have a separate off button. So exclusively only that button can switch off the LED. One button can switch on, but it cannot switching off it without this. Okay, taking the hand off is not enough. You understand? Right. So you can write an empty else and do it. No, you cannot do it. Okay. So what can we do? I will keep it this way. Okay, and I will write a separate if condition. Okay, and see what I can do. Okay. So before that, I want to tell, if I keep this code like this, what will happen? Okay, let's see. X is being read, Y is being read. We don't do anything with the Y, but we have that X part. Okay. So let's say you press the X one time. Anytime you press the button, X becomes 0. So this light is on. Okay. But you take your hand off. You see this, guys. Okay. You take your hand off. Okay. You take your hand off. But the LED is on now. Okay. Understand this very clearly. You take your hand off. Now what will happen? What will happen? Okay. Follow me up in the next video. I will say. Okay. Because it's almost 10 minutes. Just follow me up in the next video, guys.